All right. So now I want to turn our attention to putting some of these units into action. So doing a couple sample calculation with these different kinds of problems. So the first problem I have here is one where we're going to be given a solution and asked to calculate the concentration. Now, this is a bit of an overwhelming problem, but it's a good way to show how we can take the same information and express it in various units. Now, most often, you probably, won't have to express it in all these units, maybe for a homework problem, but, you might want to express it in one or two different units. But this is a good way to sort of take understanding how we can take the same information and put it in a whole bunch of different units. So we're just going to work our way through this. So start with our solution. So we prepare a solution by dissolving 50.4 grams of C12H22O11 in 0.332 kilograms of water. The final volume of solution is 355 milliliters. Calculate the concentration in the following units: molarity, molality, mass percent, parts per million, mole fraction, and mole percentage. Well, let's start at the beginning here. And we're going to start with molarity, molality. Right. Now, what do those two units have in common? Well, the top of our concentration units is moles. So first thing I'm going to do is we're going to figure out how many moles of C12H22O11 we have, because we're going to need that for both of them. So let's see. So moles C12H22O11 equals 50.4 grams. That's how much I have, divided by the molar mass. So if I add up all of these, 12 carbons, 22 hydrogens, 11 oxygens, I get 342.3 grams per mole. So if I do my division here, I get 0.1472 moles C12H22O11. Okay. So now I have my moles of solute. So let's first calculate molarity. So remember, molarity, I've got M equals moles of solute, so moles of C12H22O11 divided by liters of solution. So I already know my moles, right? I just calculated those. What about liters of solution? Well, what do I know about the solution? Well, I know the solution is 355 milliliters. So 355 milliliters equals 0.355 liters, right? So to go from milliliters to liters, we're going to divide by 1,000. Or if you want to, we need to remind ourselves of how to do that. So we have 1 milliliter equals 1 times 10 to the minus third liters. And that's how we're going to get that. So, got to remember those units conversions. So if I'm going to calculate this, I have 0.1472 moles divided by 0.355 liters equals 0.415 molar C12H22O11 solution. So my molarity is 0.415. Now, what about molality? So remember, molality equals moles of C12H22O11 divided by kilograms of solvent. Now, our solvent here is, of course, water, right? And we were told up here that I have 0.332 kilograms of water. This is how much I dissolved it in. So this one's pretty straightforward, right? It's just taking my moles, 0.1472 moles of C12H22O11 divided by 0.332 kilograms of water, and I get 0.443 molal solution. So my solution is 0.415 molar, or 0.415 moles per liter, and 0.443 molal, or 0.443 moles per kilogram of water. Okay, so that's the first two units. So let's go on and work through the rest of these units. So let's do the mass percent. So remember, mass percent equals the mass of solute over the mass of solution times 100. So in our case, right, what was my mass of solute? Remember, that was, look back at the problem, that was 50.4 grams C12H22O11. And mass of solution, so remember, the solution equals solute plus solvent. And so this is 50.4 grams of C12H22O11 plus our solvent is water, right? And it was 0.332 kilograms, which is equal to 332 grams of water times 100. So if I work this out, my mass percent equals 50.4 grams divided by 382.4 grams times 100, or 13.2 mass percent C12H22O11. So 13.2 mass percent solution. Okay. Why don't we do parts per million? So remember, parts per million is closely related, right? It's again mass of solute over mass of solution, but times 1 times 10 to the 6th, or times a million. So essentially it's the same calculation. We're going to take our 50.4 grams divided by our 382.4 grams times 1 times 10 to the 6th, and we get 1.32 times 10 to the 5th parts per million, or 132,000 parts per million. Okay. So parts per million, mass percent, going to be the same basic number, but it's going to be one as a percentage, one as how many parts per million. Okay, so let's do the last two. We have mole fraction. So remember, the mole fraction. Now, we're going to do the mole fraction of solute, so C12H22O11. Remember, that's the moles of C12H22O11 divided by the moles of solute, so C12H22O11 plus the moles of solvent, or the moles of water. So I already know the moles of this. I calculated it from the other side. So remember, the moles of C12H22O11 equals 0.1472 mole. But what I don't know, right, is the moles of water. So let's calculate the moles of water. So my moles of water equal my grams of water, right? So that's 332 grams, right? 0.332 kilograms divided by the molar mass, about 18.02 grams per mole. So if I do my math here, I get 18.42 moles of water. So now if I go back here and calculate my mole fraction, I have 0.1472 moles divided by 0.1472 moles plus 18.42 moles. And this is going to then equal 7.93 times 10 to the minus third is, is my mole fraction, C12H22O11. So what we can see is that this, though we don't have terms of mole fraction, right? The solute is a very small fraction, right? Just think of the moles. We have 0.147 moles of solute, but we have 18.42 moles of solvent. Now, again, to do this as a mole percent, we're just simply going to take my mole fraction times 100. So we're going to take my 7.9 times 10 to the minus third times 100 equals 0.793 percent solute. That's my mole percent. So we can see how, using lots of ways that we've already done, right? Still being understanding molar mass and grams to mole. So we have to pull out all of those things. We can take a few basic facts about the solution and we can express it in a whole bunch of different ways. Okay, so the last problem I want to do is taking and converting from one concentration to another. So let's say we have this. So I want to know what the molarity is of a solution that is 10.5 mass percent C6H12O6. And I'm told that the density of that solution is 1.03 grams per milliliter. Okay, so let's just break this down. So what do I know? Well, the first thing that I know is that I have a 10.5% solution. And so what that means is I have 10.5 grams of C6H12O6 per 100 grams of solution, right? And what do I need to get to? I want to get to molarity, right? Remember, molarity, right, is moles of C6H12O6 over liters of solution. So if we think about this as a conversion, right, on the top I need to go from grams of C6H12O6 to moles of C6H12O6. That's not so hard, right? Grams to moles, that's just a molar mass conversion. On the bottom, I need to go from grams of solution to liters of solution. So I need to go from mass to liters. Well, anytime we need to convert from volume to mass, we need a density. And so you can see why the density is provided here. So let's do the easy one first, or the one that maybe comes a little bit easier. So that's 10.5 grams of C6H12O6. And we know that 1 mole equals 180.16 grams. And so that, if I do the math, gives me 0.0583 moles of C6H12O6. So that gives me the top half. So what about the bottom half? Well, 100 grams of solution if I know that I have 1.03 grams per every milliliter, my grams cancel out. And that means I have 97.09 milliliters of solution. So now I have the top and I have the bottom. So I can calculate my molarity. 0.0583 moles C6H12O6 divided by 97.0. Oops. Got to watch my units, right? Milliliters. But I need liters. So this is going to be equal to 0.09709 liters. So 0.09709 liters of solution. And so my molarity equals 0.600 molar. And so that's how we can go from a 10.5 mass percent solution represents a 0.6 molar solution for this particular case. All right, so that's a couple of different problems that we can, work through, but using all sorts of these different concentration units. So we're going to wrap this up today, and next time we will come back and talk about another topic around solutions, and that is what we call colligative properties.